Welcome everyone to the Tech Talk Thursday number 15. I give you a short intro about the agenda. We start afterwards with a presentation from Sven Härtwig from narf-studios. He's the CTO there, and they're doing all the operations for apfelkiste.ch, the Swiss e-commerce shop. Afterwards, we'll continue with Andreas Schneider. He's the Chief Security Officer of TX Group. He will talk about DevSecOps. And then the last talk is from Stefan Birrer. He's talking about delivering real-time video globally at internet scale. And afterwards, we will have a quiz from CloudFlare where we can win a nice prize. More about that later. If you have any questions during the talks, please write them to the chat. And we'll go through them with a Q&A session after every session. If you want to get notified if we do the cuttings of these presentations, please follow our YouTube channel. Everything is recorded and shared later. Of course, you can also switch back in the live stream and watch the live stream again. Our next events, we'll have the Google Cloud Meetup at the 16th of March. We have already one speaker confirmed from Ricardo. And Dan Acristini, if you're watching right now, he has committed also to do a speak. I'm excited about the topic. And then next Tech Talk Thursday will be around April or May. If you have anything to contribute or talk, I'm happy to check if this is suitable for our Tech Talk. So the quiz. You can win one of these three prizes at the end of the presentations. Uwe Martin, who is the quiz master from CloudFlare, will guide you through the quiz. It will be a 10-question quiz, and it will be real time. So after every question, you will have a leaderboard, and you have to answer questions. And be aware that it's also important to answer the questions fast, not only right. So you get more points the faster you are. And I recommend to use a separate device than the screen you have on than the YouTube you're watching, maybe your mobile phone, to access this app. You need to do the answers. So that was it from my side. I'm handing over now to Sven Härtwig, and thank you very much.
Okay. Hello, everybody. That's my talk about CloudFlare and why we love it. That's wrong. About me, short summary, my name is Sven Härtwig. I'm the CEO of narf-studios, and we are a digital agency with a strong technical focus based in Hamburg and specialized in e-commerce projects with Magento. Our customer, we have apfelkiste.ch for about 6 years now, and apfelkiste is pretty big. You might know them. Currently, more than 25,000 unique products every time on stock, and up to over 9 million page views a month. And they are always fast growing. They have always been fast growing, and they will always fast growing in the future. And with apfelkiste, we are on the CloudFlare setup for 5 years now. Problems we had in the past. Before apfelkiste went to CloudFlare, they have been at a hosting company in Berlin, which was not really satisfying. They had several problems with their varnish and all that stuff, and it was not the best solution for apfelkiste. So the problems we had: get out of the line of potential attacks, DDoS and other known attacks, known exploits, and so on. Of course, we wanted more speed because we always want more speed, and we had to optimize processes. Like the best process we had is image processing. Magento itself creates an image for every single view. So card is a single image, product view is a single image, and this process has had to be optimized. And of course, the goal was to reduce the workload of the web servers, so web servers could do other things they have to do, and let CloudFlare do other things which CloudFlare can handle better than we can. So the first thing we did is move our setup to CloudFlare, and this is a really cool feature of CloudFlare, that you can proxy your DNS. So that means that your IP address of your origin server is not visible to the internet itself. CloudFlare will only show their IP address, and your IP address is hidden. But a short notice: if you are moving behind CloudFlare, do this with a new IP address, because it can be that an attacker may also know your IP already. So it doesn't work that you put your servers behind Cloudflare and think, okay, now I'm safe because I'm behind Cloudflare. Because when an attacker knows your IP address, he can put all his attacks onto your IP address directly. So this is a pretty important notice, that when you are moving to CloudFlare, please use a new IP address for your servers. So when you are behind CloudFlare and an attacker puts attacks onto your website, CloudFlare manages that for you. Another thing is CloudFlare can manage known exploits and the most common known threats. So the web application firewall of CloudFlare does a really good job, and we had no problems so far. But of course, it's not 100% secure. You always have to secure your application by yourself. Cloudflare has something like rate limiting. That means that you can put a filter in front of your forms, for example, and you can configure a limit that users may only put maybe 10 requests in 1 minute on this form. Otherwise, they are blocked. And you can also add fire rules by yourself. So this is also your firewall itself. This is a display of the Cloudflare backend, and you can see this. These are the managed rules. So the managed rules is a rule set Cloudflare provides by themselves, and it is made for your application. And so the most used applications like Magento, WordPress, PHP itself. And these can be turned on with only one click. And I think that's a really good thing. So coming to speed, at first the old setup it was pretty slow because we had a not really good configured Varnish as a caching layer. The old hosting provider had some problems to configure it, and the result was that we always had caching issues, that a page was not cached at all, or the TTL was too low, about 2 minutes, so the pages were not cached, and this was not the best time we had. Another point was that there was no CDN at all, so the images were delivered by another subdomain. Was also not the best solution. We then put a CDN provider, an external CDN provider, onto that to deliver our assets, but the latency was worse than without a CDN, and we also had no optimizations. The web servers had to do all the stuff by themselves, like image processing. So what does slow mean to an e-commerce business? You all know that. If you are a user and the website, the online shop you're visiting is slow, you're annoyed. And the worst thing which can happen is that the customer leaves. So we have an impatient user here and a very impatient user here, and this one is already gone because your web server is only too slow. And another thing is that search engines, they don't like slow websites. Yeah, they only want the best for the users. Why does this matter? Because users hate a slow website, and if they are gone, you're losing money. Search engines are also creating a score of your website, which is based on the speed of your website, and this means, yeah, you are getting less traffic because your rating is lower at the search engines. That means you are losing money too. And what I can assure you that each improvement in speed performance matters and enables you to earn more money. Because thinking of Germany, when you're in a train and try to access a website on your mobile phone, this can be pretty slow. And if your page has been optimized for speed and performance, a user might be able to access your website even if he is on a train. And that means you're earning money because visitors can visit your website and can buy products from you. With CloudFlare in front, 5 years ago we went to 9, and we moved the setup to CloudFlare, and that was a really good decision because we had a fully working full page cache with a CDN, and it was really easy to handle because all we had to do is we put the DNS in front of our web servers and only configured some page rules. Of course, we had to create a module which can purge caches in CloudFlare and maintain the connection between CloudFlare and the shop. But that was a task of 1 or 2 days, and then it was done. Another thing is you don't need any configuration like VCL configuration for varnish caches. Like I said before, the old hosting provider was not able to give us a configuration, and he was days on this configuration to make it work, and it never worked really well. And this, in fact, means that for us, CloudFlare is really easy. You don't have to put any configuration to it. You don't have to learn another configuration language also. You just have to add these page rules. And these page rules are pretty simple to create. I can show you that. I can show you that later in another slide. how easy they are to maintain. So with CloudFlare in the front, that's the image from the slide before. With CloudFlare in the front, your origin server may enjoy his life because all the traffic which was on the origin server is now cached by the CloudFlare CN, and all traffic which is coming to your website is delivered by CloudFlare. And this leads to happy and satisfied customers because they can access your website very, very fast. And it also leads to a search engine which is happy with your with the speed of your website, and of course will put up your rankings because Lighthouse speeds, Lighthouse scoring is better than before, and this means that your the quality of the website will increase. So CloudFlare helped us so far with a very low latency for DNS lookups and response time for the content, and that is really, I have never seen better performance before at a CM provider. And the edge cache of CloudFlare helped us a lot because, as I said, it's easy to maintain, and it works like out of the box. Yeah, you are putting CloudFlare in front of it, and whoops de whoops, you have your fully working cache. Speed optimization tools CloudFlare offers are, for example, auto minify. You can minify your HTML, CSS, JavaScript, which is coming uncompressed from your origin server, and CloudFlare can minify and compress these assets. Actually, we are only using this for CSS. HTML is done by the server, and JavaScript, I personally are, in my opinion, JavaScript minifying leads sometimes to problems, and you want to avoid these problems, because I experienced that once that minified JavaScript code put some errors to life, which was not that funny. Because of that, I'm a bit careful about JavaScript compressing by other services. We are doing the compression, so the building of our JavaScript libraries by ourselves in the build process, so we don't need this in our setup. Another thing is polish, which can also be activated with one click. What polish does, it reduces the file size of your images. So it removes non-used data like meta tags or other metadata from the images, and it also, you can configure these values. It also creates a compression on it, so you can leave CloudFlare with polish alone, and it will compress and optimize your images, which are then delivered to the customers. Then there's broadly you can activate for CloudFlare. That's you all know GSIP, I think, and broadly is another algorithm. HTTP2 prioritization is offered by CloudFlare, and a TCP turbo. That's optimizations done by CloudFlare. You have the rocket loader, and now I have to think about it that I don't tell you the wrong thing. Raygun is a really good tool I've read today. With Raygun, you can put changes of cached data. So let me start again. With Raygun, you can change already cached data in CloudFlare by your origin server. So you only send data which has changed to the CloudFlare cache object, and only this is will be changed. To be honest, we don't use this yet, and I can't guarantee you that it works by 100%. So Mirage is still in beta. That's because of that we don't use this yet. But Mirage has really good power. It shows, it looks for the user's device. So it makes a difference between a desktop device and a mobile device. A desktop device and a mobile device, they each have to get some, they have to get different image dimensions and quality. And Mirage does all this by themselves. So it looks for the device, for the dimensions, and creates a resized image for that user. And another cool thing we are using is AMP Real URL, but unfortunately that is only working for Chrome Android right now. With that functionality, you can have these AMP pages, the accelerated mobile pages, on your domain itself, because normally a AMP website looks like google.com/amp/blah blah blah, and with this functionality you can put your URL in front of it. So page rules. Generally, every asset and root, only GET request can be stored in the edge cache configured by a page rule. It is also possible to cache post requests by a worker, but that's another story. To purge these URLs, this is really easy. You only have to go to the dashboard of CloudFlare or use the API. So possible ways to purge a CloudFlare cache object. So the background is that each URL with a query string behind it creates another cache object in CloudFlare. So for example, this is a cache object. We will look at this on another slide later. This is one cache object, and if I have a get parameter behind it, like UTM source, like if I'm getting this URL from a Google campaign, this will be another cache object. So, and to purge these cache objects in CloudFlare, you can do this by the URL, by the host name, by tags, which is pretty cool, or by prefix, or of course you can purge it all. I don't know if others had the problem by themselves, but with the varnish configuration, we were not able to purge only the home page. So in this case, it would be this URL. This was pretty annoying, and we were happy then when we were at CloudFlare that we could do this. So this shows a simple page rule in CloudFlare, and these things are really easy to maintain because you just add a new rule and put here your root into it, and then you are setting all these settings. Most important for this rule is the cache level and the edge cache TTLs. So this means this rule itself means that every root which is like this pattern will be cached for 7 days until it is being purged by a request. Page rules itself are mostly used to create caches so that we can say, hey, with this pattern or this route, please cache this for maybe 2 days or 3 days or so. But we also use page rules to specify caching of other objects, because maybe our media folder, images may have a longer time to live than HTML or even JavaScript files, because JavaScript files may change the next day. An image of a product, maybe it will never change, so we can put a TTL of 30 days onto it. And what you also can do with page rules, you can see here, these options. There's a long list. My screenshot only shows some options of this, but there's a long list you can what you can do with CloudFlare itself. And what we also use it for is for warnings. Not many, but some hard forwardings like a 301, a permanent redirect. For that, we use these CloudFlares. And the cool thing about this, you can move these page rules in their direction, and always the first which hits this configuration you did in this page rule will be executed, and the rest of it is not be executed. So in my opinion, that's really easy to maintain. The problems with purging caches. When we first started with CloudFlare and the module we have created for it to purge caches was really easy, because we had products with which were related to some categories, and we just had to collect all these URLs of the categories with the products on it. This was okay for the beginning, and we purged CloudFlare caches always by the URL. That's totally okay, but not if you have to purge 1,000 of URLs, because our customer was growing fast, and products increased by a lot, and categories increased by a lot. And so that means that you have to purge a lot of URLs. And the thing is that each purge request on the CloudFlare API is limited to 30 entries. So imagine you have to purge 2,000 URLs with a package of 30 entries each API request. This can take a long time, I can assure you. Another thing about purging CloudFlare caches is that they always say that to you in the dashboard, if you are purging caches, that it can take up to, that it may take up 30 seconds to purge all caches worldwide. I have experienced that once, that it has taken longer than 2 or 3 seconds, but in my opinion, this is also okay, because when you're looking at the worldwide node network of CloudFlare, they have to purge maybe some gigabytes of your assets in all their caches, and that's okay. Of course, these 30 seconds make it difficult, make it more difficult for your cache warming processes, but you will find a solution for that as well. So here we'll explain the purge process by URL and tag. Think of a product like this Kabel, which is related to 3 categories. When this cable is out of stock, I have to go to CloudFlare and say, hey, please purge this URL, and purge this URL, and purge this URL. Of course, I can put this into a single request because it's below the 30 max entries. But imagine you have thousands of this. Yeah. So this can take a long time. Another solution is that you can put a tag on each HTML doc or each asset. Yeah, you can put tags on JavaScript files, on image files, CSS files, whatever you want. Yeah. The solution we had then was that we add a response header with the tag Kabel by our application. That means that all of these URLs, which are cache nodes, cache objects in the CloudFlare, all of these cache objects have this tag Kabel. And now, when I want to purge this product with all the related URLs, all the related categories, I just have to go to CloudFlare and say, hey, CloudFlare, please purge the tag Kabel. And this means that all of these URLs which had this tag are being purged instantly. And this, well, it saved our asses because this is really fast, and you can purge thousands of URLs of your products by only one API request. Another thing we are using with CloudFlare is the workers. Workers were, as I remember correctly, were introduced in 2018 by CloudFlare. And the workers are a serverless execution environment based on JavaScript. And this is really cool, because all you can do by JavaScript, you might do in a worker. Things you can do by the workers is change requests and responses, which is really cool. Fetch and send data from or to other origins or our web server in the background. I will show you an example. Store and use limited data in the environment variables, which is pretty awesome. And you can replace HTML without purging caches. So here's an explanation about the cache objects. As I said before, every URL with a get parameter on it, every URL is a single cache object in CloudFlare. So this is a cache object, and this is a cache object. You see the green circuits here. This represents a cache object. And if a user tries to request this URL. And let's imagine this URL is also already in the cache. And the user tries to access this URL, he will get a miss from CloudFlare because the cache object itself is not existing already. So the data has to be fetched from the origin server. But we have workers. And with the worker, we can change the request, and we cut the get parameters. So in CloudFlare, the thing which is being requested is this URL, and this URL is the same as this one. And the best place we have put this cache object to life by our cache warming. And what happens now is that a customer requests this URL, and we don't care what get parameter is on it. All get parameters which are not used by the site are being cut from the URL, and CloudFlare is only asked for this URL. And what happens is that CloudFlare will not access this cache object. So it will deliver this cache object, and this results in a hit instead of a miss. And we had this problem with a affiliate like recommendations on our website, and we had to find a solution to make these links much more faster. And then we had the idea to use a worker and just cut these segments from the URL. But you might think that any tracking or JavaScript or something else might not work then, but that's not true. For the browser itself, it doesn't change. Yeah? The request is only being cut in this environment, and we only want to get this cache object. So the thing that I have mentioned before, when we have a full page cache and we need to change data, normally you have to purge the whole cache for the page. So let's imagine you have a product like a bike, and the bike is going out of stock. Normally you have to purge the whole HTML, the URL, to purge the cache of this article, of this product. And this is not the best solution because it is out of the cache, and users are coming to your website and are experiencing a slow website because maybe your cache warming was not that fast, and put it back to a working cache object. So what you're doing is typically you will use Ajax just to ask for other data. Of course, the stock example is not the best for this solution, but think of a advertisement, an advertisement on the front page, and the best example is all these advertisements on pages like food recipes. Yeah, every time I read some recipe for a meal, I scroll down and I see I'm already reading the text what I have to do, and then an advertisement is being loaded by JavaScript, when the document is already completed. And this leads to a jumping website. And I hate jumping websites because you're still reading the text, and then the advertisement is being loaded, and then the data is put into this HTML, and the height changes, and the whole page is jumping. I hate that. Yeah. So you all know this solution that your full page cache, you don't want to purge your caches because cache warming is maybe it is taking long. The process by itself is complicated, or anything else. So you're using Ajax requests to get data from outside and hydrate your website, your cached website with this new data. And this is not really fast. Yeah, the result is that, as I said, you have jumping elements, which I personally hate, and you have a slow loading. And another thing is that most of the tests, like Lighthouse also, will put your score down because, in fact, your website is a slow loading website, which is not finished. But there's a CloudFlare worker, and it can do this for us. Just imagine you're requesting a URL, and on this request, the worker by itself in the background asks another server, like our Origin or any server out there, which can answer our question, like this sentence: is Trump still president? And when you are getting this data, you can put this data into the cached object and replace HTML. So maybe you put a div with the ID replacement into your HTML file, and then you have this HTML file in the CloudFlare cache object, and the worker is able to replace this div with the ID replacement with his own code and stuff and information, like the information he requested there. And this leads to that you can deliver your HTML without purging your CloudFlare caches. In the result, you don't need an Ajax request. Your website is not jumping, and the information is already included in the delivered HTML. But it is possible to do this more faster. Not much more faster, but faster, because the request the worker has to do to the outside, and maybe the outside server is a bit slow, or the answer is not the best because the connection is bad. It will lead to a slow delivery of CloudFlare itself, because the worker first has to get this information so he can deliver the changed HTML. In this case, you can use the environment variables of the workers. So let's imagine on the 20th January, we started a process and set this variable in the worker to false, because Trump is not in the office anymore. So on the future requests on the cache objects, the worker will just look into his own scope and will see, okay, my variable says it's false. So I can replace the HTML node with this information. And in case of Trump is still in the office, this will be the result. So the result of this is that, like before, the HTML is delivered with the current information you stored in the worker itself. And that's a bit faster than the other solutions where the worker has to fetch the data from outside, because you are minimizing the request. So you are eliminating the request. You don't need that anymore, and the data is stored at your worker. So that's from me. Any questions?
Okay, so thank you very much, Sven, for your talk. We have one question in the chat in German. So if you have any more questions, please write them to the chat. The question is from Christian, and it is, wie wertet ihr aus, was die Leute anfragen, wenn ihr nur noch whitelisted Objekte ausgebt?
Geht es da um die Cache-Objekte?
Vermutlich. So, wie wertet ihr aus, was die Leute anfragen, wenn ihr nur noch whitelisted Objekte ausgebt? Das kam etwa in der Mitte vom Vortrag.
Also es bezieht sich wahrscheinlich, ich antworte mal auf Deutsch, das ist auch einfach für mich heute. Bezieht sich wahrscheinlich auf...
Also er hat gesagt ja.
Ja, es bezieht sich wahrscheinlich darauf, dass wir einfach die URL dahingehend beschneiden und bei CloudFlare einfach nur noch dieses Product.html ankommt. Wenn es da ums Tracking geht, also das Tracking an sich läuft ja normalerweise bei den meisten auf JavaScript-Basis, und im Browser bleibt alles gleich. Also im Browser bleibt hier dieser Query-String bleibt weiterhin erhalten. Und die ganzen Tracker und so weiter können das natürlich weiterhin machen. Uns geht es nur darum, dass quasi dieser Query-String hier wegkommt und CloudFlare denkt, okay, das ist genau diese eine URL und wir brauchen ja nur den Content aus diesem grünen Kreis. Und den wollen wir zurückbringen. Und das ist eigentlich alles. Und Trackings, also wie jetzt Google Analytics und so weiter, die kriegen das natürlich weiterhin mit, weil es alles clientseitig läuft. Würden wir das natürlich serverseitig auswerten wollen, dann hätten wir natürlich ein Problem, weil es kommt ja auch nicht zum Origin-Server durch. Aber in so einem Fall könnte man theoretisch auch den Worker benutzen.
Okay, danke. Also Christian hat noch geschrieben, Fragezeichen Produktfarbe gleich grau. Okay, er hat geschrieben, alles klar. We have a second question from Sam, saying he's not a front-end expert, but why not use pre-compiled asset? You get different static file name every time to avoid purge cache.
Das ist richtig, das machen wir auch. Deswegen ist auch das ist eine englische Frage. Answering the question for the not front-end expert and the pre-compiled assets. That's correct. We are doing this with JavaScript and CSS assets. So we just put a version number behind the asset when it is included. And because of that, we can put a very high TTL, so time to live, on these assets by the page rules. And this is also a thing Lighthouse Score and other scoring tests are mentioning, that the TTL of such assets is pretty high. But for a HTML document, we have to purge the cache because we can put a version number onto it, because HTML files like products are used in advertisements like Google AdWords or affiliate networks or so on.
Okay, thank you very much. That was the last question. So now we switch over to Andreas.
Good. Welcome to my talk, everybody. So I will try to bring you into the security world and about the most effective security measures at scale. We also work with CloudFlare in our company. So TX Group is a large CloudFlare company, but actually we just use it, or mostly use it, for security reasons, not for caching reasons. But it's good to have that talk before about the caching part. I was not aware of that. So, who am I? So my role is Group CISO, so I'm Chief Information Security Officer. So I'm responsible, or more or less, if a company in TX Group is hacked, I'm held accountable for that. So that's what usually, hopefully, does not happen. I'm doing security now for over 20 years, from technical management and all that stuff. So I also worked in different companies, started in banking, ended up in a startup that never left the startup stage, so I know how failing feels like. And being in a garage for a long time, I also was in the telco industry and now in the media industry for a long time. I'm not just doing security, I'm a tech enthusiast, and I'm also co-founder of 42.ch, so just that's about me. And one important thing is that security needs to shift left. There is some call it DevSecOps, others call it AppSec, and shift left is something we called our strategy for product security. We called it shift left, and I'll explain what this really means. Just a few words about TX Group. So what is TX Group? So most people know 20 Minutes in Switzerland, or maybe the Tagi, so Tagesanzeiger and the paid media titles. So that's actually, yes, that's also part of our company. But we have a couple of other companies in there, like in the TX markets. There's Ricardo, Tutti, HomeGate, Car4You, Jobs.ch. We have Doodle for calendar invites. We have Z2 for video streaming. And then even we have venture capital organization in our company that is doing investments in little banks, mostly fintech companies like Lücke, Neon, and others. So we do a lot more than just printing and news, what most people already know. One that all the companies we have in common is that we are a cloud company. So we are cloud companies, you could say. So we have several cloud companies that belong to us. And cloud company usually means we run like 80% of everything we do, we run on AWS, and the rest, the 20%, we run on Google Cloud Platform. So for example, Ricardo is doing a lot in Google Cloud Platform. They run Kubernetes there. If you go to HomeGate, for example, they run everything with Lambda functions serverless in AWS. If you have our content management system for example, for Tagesanzeiger, that's actually running on virtual EC2 instances. So we have, from a technology stack, we have everything. So what do we do? So the first thing is, for smaller companies, it's usually something that many know, but we implement Beyond Corp. Beyond Corp no one knows, but Google has invented that. It's called a zero trust architecture, but we get rid of the internal network. So our clients, so like my client, my Mac here, if I work at home or in the office, it's the same. I'm outside the network. So our network is just an internet access, meaning that if my device is infected, I can't infect the systems in the internal network, so production systems or other systems. So if you are just a cloud company, that's normal, but many still have the architecture of an internal network with VPN, so we go VPN-less. And what we do is we collect all the log files from our IDP. We use Okta. We collect it from Google Workplace, from the Google Cloud Platform, from AWS, and from the clients with a company called Cybereason. That's an Israeli company doing endpoint detection and response and other fancy stuff. But in the end, we just correlate all that log files and search for suspicious behavior. So it's behavior-based detection that we do there, and then they do their machine learning and magic on that. So everyone can do Beyond Corp. It has been invented by Google in 2011. So if you're interested, just Google for it in Google, then you will find Beyond Corp. it's a fantastic concept in trying to get rid of the risk of malware. So I talk about that because it's one element. The client is one element, especially from the developers. So if you have an infected developer or someone gets access to your developer's client, you are screwed. All the measures you have will fail because the attackers can go through the developer client, commit code, and from there on it will end up in production. So that's why this is an important key element. Like I said, we shift left. Everyone has to celebrate that. So we have, I think, 600 engineers and developers in our company, and we try to bring that to every one of them, that we do security from the beginning on. So not in the end. So if you deploy, let's take CloudFlare, and try to solve all the issues you have with CloudFlare, you will fail. Definitely, you will fail, because you try to build a wall around the mess the developers have created, or the engineers. So you have to rethink that. If they do that from the beginning on in the right way, I wouldn't say you don't need CloudFlare, you still need that, but you don't have to implement it like a web application firewall to prevent intrusions and stuff. So if you have good code, you have less problems. So that's why shifting left solves problems earlier. So what does that mean? This is a very super simplified and not completely correct CI/CD pipeline extended to the developer itself. So something that you need to do is really, if you go before you really enter the CI/CD pipeline, you have to train your people. That's a key element. If you have shitty developers, you can't solve it with technology. So what we have is we train developers how to hack. So how to hack websites. If they know that, they also know how to prevent that from happening. So there are good tools available. For example, Secure Code Warriors is something that everyone can try out in small teams where there are competitions between developers and engineers. On our client computers, we deploy EDR. That's some kind of next generation antivirus that's not working hash-based but behavior-based. And it's, again, everyone can do that, but it's worth investing in it. Even if you run a Mac, even if you run a Linux, we deploy that everywhere. So there is no difference. There are small other things we do. For example, we deploy YubiKeys almost everywhere. So with the YubiKeys, we enforce the 2FA everywhere where it's possible. And we can store certificates on the YubiKey. So it's something quite fancy to do second factor authentication with that. Now, what we then do is the code that is being committed, we do source code analysis. There are a couple of really good tools out there. So Deep Code is something that we use. It started as a spin-off of the ETH Zurich. It's now acquired by Snook, but you can run it for free up to 25 developers if you have a team up to that, and they run machine learning against your code to find flaws in your code. So that's, again, when the developer is developing, you get the feedback quite fast back to the developer that something is wrong. We use that next to Sonar Cloud. Sonar Cloud is just for code quality, a good tool. It's free for smaller teams and public repositories. If you have closed private repositories, it costs a little bit for line of code. A tool I would look at, so we don't use that yet, is SemGrep. That's a completely open source tool invented by Facebook. Now they did a spin-off open source tool for that, and they run a really effective engine against the code. So it's like grepping through your code in an extremely fast way. That's a tool I would definitely look at. There are commercial solutions out there that cost insane amount of money, but with tools like SemGrep, Deep Code, or Sonar Cloud, you can do that in a very low budget way. You have a question right now? You can ask, yeah, that's fine.
Yes. So are these tools language agnostic, or that
Mostly. So TypeScript, JavaScript, Go. So you have a lot of languages that are covered, even Java and other languages. If you go for COBOL or some old-fashioned languages, should be covered. for sure for Sonar Cloud. I'm not sure for Deep Code, but they extend that.
Yeah.
Deep Code, for example, also has an IDE extension, so you can have it in your Atom, Visual Studio, or whatever, so the developer directly gets feedback. And that's an important part, because then you don't have to run tests afterwards. It's annoying to get that from your IDE that you write bad code. At a certain point, you will learn to write good code. So this is the training element out of that. Then something that usually happens when hackers get in is outdated libraries. It's a quite simple thing, and it's so easy to solve. So there are tools like, if you go use Golang, you can use an open source tool called Nancy that is checking if outdated libraries are used. You can use npm audit, you can use Snyk. Snyk has a couple of languages that they support without any costs. So checking libraries is a key element, so everything keeps up to date. Then, as soon as you have written the code, you commit the code. And what we do there, we run a couple of tools like TruffleHug. That's for AWS, so that's the truffles, finding the truffles. So this tool finds secrets in the code, so passwords or access keys or these kind of stuff. It's just finding like 70 to 80%, but it's one of the key issues if hackers find somewhere an access code, somewhere in a commit, some password. This is the way many hackers get in, and with tools like that you can find that very early. So you should, as a developer, you should use tools like the AWS Secrets Manager. You should never have real passwords somewhere in the code, but actually this is happening quite often, very, very often. What we then do is we usually use signed commits. So with the certificates we have on the YubiKeys, so if a hacker would get access to your repository, this happens quite often, he could not commit any code because he needs a valid certificate for that, for signing that. And you can work with pull requests and all that stuff, but you have to make sure that there is some kind of quality check before the code is really then automatically running through the CI/CD pipeline. Like with the library checks, there are ways to find outdated libraries directly in the repository. For example, Dependabot is a very cool open source project that checks every library you have. Because maybe if you just do that when you commit, if you just commit, for example, for a small project, let's say 4 times a year, you would only check 4 times a year for an outdated library. Dependabot is checking all the time, so if you have an outdated library, it opens up a pull request, for example, automatically to upgrade that library to a new version. That's a very simple method. It's open source, you just have to use it. There's also RenovateBot as an alternative, or if you are on GitHub, there is GitHub Security Alert, depending on the pricing plan you're on. But Dependabot is a good example, what we, for example, use. Then, if you enter that automatic stage, you have that 2 big parts. So the testing, whatever you do in there, there might be another way you do that. But if you test, there are some key elements what you then can do. Again, you can run these code scans against that. Tools like SemGrep and DeepCode and Sonar Cloud are good, and they make sure that you only can, for example, Sonar Cloud is doing that, you can only go forward if you pass a quality gate. And a quality gate can be that, for example, you have comments done in the correct way, that you also don't find any critical vulnerabilities like cross-site scripting or something else in there. So this is something I would always use, and automate it. Don't do things manually, try to integrate it in your CI/CD pipeline. Something we don't use are abuse tests. This is more a theoretical thing, but you can run, if, for example, like Netflix is doing that, they take down regions, servers, they, for example, increase latency, but intentionally, and you can run their tests also against your infrastructure or against your code in that testing areas. But this is this is quite advanced, that's why we don't use that. So it's difficult to do that at scale. So that's why we at the moment don't use that. But what we do is we regularly scan our cloud environments. So if we go, for example, to AWS, we use Prowler. That's an open source tool. The C-Suite is also open source, but Prowler, it's an open tool on GitHub. If you run Prowler, it will search and audit your whole configuration. So if you have, it checks the IAM rules that no one really understands. If you have a large AWS environment, it gets so confusing. It really helps to find weak spots in there. But also if you have, for example, open S3 buckets, so the whole S3 bucket configuration parts and other parts. If you are running on Google Cloud Platform, they have integrated Forseti. That's also a very good tool to check the Google Cloud Platform configuration. That's also open source. And then you have the results. You have them in the Google Cloud Platform, somewhere in the security command center. There are some things are centralized in the Google Cloud Platform. Both make sure that you check your infrastructure, so that the infrastructure that you have set up, either a Google Cloud platform with the machines, or if you have Kubernetes, doesn't matter, they usually find it quite well. So the base configuration. Then there are additional scans that you can run. One example is Gauntlet or BDD security. Super complicated. You can, for example, try to inject latency somewhere, like the abuse tests. But actually running that at scale means that your team must already have done a lot of other stuff. So it's just that you have seen that somewhere. You can run additional security scans with Gauntlet and BDD security, but I would just go for Prowler or Forseti. This really brings a good result on your cloud infrastructure. And then there are the web application scans. You can either run them against your live system, so your production system, but you can also run them in your CI/CD pipeline. So actually there are no good open source tools from my point of view. We use Detectify. That's a crowdsourced web application scanner that can just completely run via API. So as soon as you commit new code, it runs through your CI/CD pipeline. At a certain point, you can trigger the scanning with Detectify. And the difference between, for example, Arachne is an open source scanner. The difference is just that it's a SaaS application. You click and it's really working quite well. And it's enriched with additional findings. So if people, for example, attend bug bounty programs, so I'll explain that later, but if someone is researching vulnerabilities and is earning money with that, he can sell that finding before it's made public to, for example, Detectify, and they integrate it as a test module. So you have the known vulnerabilities in a large database, and additionally you have the unknown vulnerabilities or a couple of crowdsourced found vulnerabilities in there. So we use that like Spotify or Atlassian. They also use that, and they integrate it in the CI/CD pipeline. We do both. So we have it in the CI/CD pipeline, but also we run it against production. I would invest a little bit of money to run that. You pay per team, more or less. So small prices, but you get a much result out of it. And then what we also do is we check if you run containers, so either Docker or Kubernetes. We run infrastructure tests against that. There is one, for example, called KubeBench. That's one of the best that we found out. KubeBench is an open source project, so that you can just use it. Like Prowler, if you run Prowler and KubeBench, you more or less know that the base infrastructure is set up correctly. And we run that regularly so that we make sure that things are kept in a healthy state. So if we move forward to more the production view, so if things are there, it gets expensive. So all the steps earlier are not interrupting anything in your website. So if you now do things, it gets really expensive. One thing is the web application firewall. So we run things that natively run on AWS, we usually protect with AWS WAF. So there you have DDoS protection with AWS Shield. On top of that, we have the commercial WAF product to protect us against DDoS attacks, mostly just DDoS attacks. And you could say the other part of our company is using CloudFlare for DDoS protection. We also apply a couple of WAF rules, but if you do a lot of measures that I mentioned before, you usually don't need them. So there should not be any cross-site scripting or SQL injection or whatever in there, because you already found them. So we try to use CloudFlare mostly for DDoS protection. The same for AWS WAF. And it really depends where you have things hosted. Maybe from a pricing perspective, it makes more sense on AWS or on CloudFlare. For both, we use Terraform to deploy our rule set there. So it's something we don't use the UIs, we just do everything usually with Terraform. Then something we do audits. That's the boring part. So we have, let's say, one time a year, I come by with for example, our digital companies, and we test them. So we have manual auditors there. That's the old-fashioned way of doing things. So we tend to move everything to bug bounty programs. So we work together with a platform that's Bugcrowd, where we pay researchers if they find something. So if you, for example, go to 20 Minutes as one example, that's running on AWS, Kubernetes. There we have, it's not yet public, but we have a almost public bug bounty program where we have around 800 researchers that search for vulnerabilities. So, and it's a first come, first serve principle. So if a researcher finds a bug in there, it can be rewarded only one time. So it's like a competition between the researchers. And we don't have to care about the payout. That's why we do it via a platform. So in a larger organization, it gets very complicated with finance and controlling. So if you have a researcher reaching out to you that he found something, you can do that by your own. Everyone can run a bug bounty program. The problem is if the researcher then comes from, for example, I don't know, from Iran and is requesting Bitcoin, it gets really complicated from a controlling perspective without an offer to make that working. So if you have them in such a bug bounty platform, you have a wallet and the platform is taking care of the payout. So that's why we work with such companies. It's, for me, one of the best measures. So if you take Detectify as a vulnerability scanner and a bug bounty program and a DDoS protection with things like CloudFlare, that's the most effective way of dealing with security. You should never run a bug bounty program without having other steps done before, because you pay if things come in. And if you have a limited budget, and it can run out really in minutes, but it can also be very sustainable. So, for example, in the beginning of when we started with more than a year ago with 20 Minutes, it was on the day, it was like exploding in the inbox, and I thought, oh my goodness, my budget, I'm getting really nervous. But after now 1 year, we have 1 to 2 findings per month. And that's a good thing because developers get used to treat security as a bug. They use it, they treat it in their tools, and it's easier to look at 1 or 2 bugs per month rather than one time a year or audit with 30 bugs, for example. Then you interrupt everything. So with that, you have that continuously and you distribute that over the year. And if you have a very secure platform at a certain point, you don't pay out anything. So it becomes cheap. The beginning is you get nervous, it's not that cheap, but in the end, it's really one of the best ways of doing that. What we then do is, it's not on that slide, but if we find that, for example, a problem in our login system, we want to make sure that this never happens again, we take that one, give it over to Detectify, and create a module out of it, a testing module. So we do regression tests for security with that, knowing that it's not like normal regression tests are done, but it's a good way to make sure that these things don't come up again. So, something that is not easy to implement if you are in a smaller organization, but we collect all the log files that we have, for example, from all the AWS logs end up in CloudFlare, so we collect all of that, and we run that in our SIEM. So it's more or less a security information and event management system. It's just a log system. You can use Splunk or other tools. We have our external vendor who's doing that for us, and he's then finding, for example, if someone is creating an open S3 bucket, it creates an alert. So if you have reached some kind of healthy state and you have all the log files available, you can make sure that it doesn't become unhealthy with that. So you have to create some rules by your own, but if you want to make sure everyone is using 2FA, no one is using an open S3 bucket, and so on and so on, we have a lot of use cases there to make sure that nothing gets unhealthy. That's where you can have super expensive solutions. You can also set everything up with Elasticsearch. So it's not rocket science, it's just a matter of if you have the right people to set things up. What we do, but I also didn't highlight it because it can become also expensive, is a threat intel. So there are companies that look for information in the darknet. So we use digital shadows, but it's, for example, you can grant them access to your code or to you name the GitHub repositories, you name the VIP users, and then they run their searches if it comes up somewhere in the darknet that people plan a operation, so a hacking operation against your organization. So mostly nothing comes up with that, but what we usually find is compromised accounts from users we have, so from employees. So if they get lazy and access a forum with the same username and password, or with their Google account, for example, if you have that one, it can become dangerous. For me as a CISO, it's really complicated if I want to reach out to the users. If it's just a photo forum, it's fine. If it's a dating website, it gets a little bit more complicated. And actually, on a large scale, these kind of things can happen. And it's difficult then to make the user aware, by the way, if you do some dating or stuff, use another account for that. Don't use the same account. So, and actually, these are one of the main reasons hackers get in, because they steal accounts and credentials. So 2FA is one of the simple things to get rid of that problem. Then there's something we already use. These are honey tokens. In the end, it's the idea of having a honeypot. So you make fake websites, and you can also make fake Lambda functions running that are accidentally, they look like someone could access them publicly, and you just look what people then do. So it's quite easy to point people away. Canary Tokens is a very cool project doing that, and company. They create that kind of honeypots, also based on serverless. And the idea comes really from the mining people. They had canaries with them because they died earlier because of the gas, for example. So they died, and they knew, okay, now we have to run. So that's the idea of the canary tokens. There's a project called Spacecraft to create honey tokens on scale on AWS. So that's a fantastic tool. And then the last thing is what we What we not yet do is, but it's chaos engineering. It's something Netflix has started with the chaos monkeys, so you can randomly kill virtual machines, kill, for example, containers or whole regions, just to make sure that your infrastructure stays resilient. So if you, in the past, if you worked in a bank, these were disaster scenarios. So you did that one time a year, and usually you were able to survive that scenario, but nothing went like expected. And for example, Netflix is just randomly running these killing monkeys, that is killing regions, servers, functions, everything they have in their infrastructure, meaning everything is in such a redundant and resilient way that it can't fail. So that's how that works. So it's a super complicated. You can do a lot of stuff in every step, and you can fall asleep. So I try to simplify it. Things that, from my point of view, are really the best ones. On the left side, it's a deep code or a semgrep. So to scan your code, it's something like Detectify scanning your web application, and tools like Dependabot and SonarCloud to check for outdated stuff. So this is on the one hand what is very successful. On the right side you see CloudFlare. So you have to take care of DDoS protection, because the best code doesn't protect you against DDoS protection. And we had 1 month of DDoS attack. So we were under attack for 32 days, every day, several waves, and the waves were really big. So our infrastructure without DDoS protection would not be able to scale up in such a way. So we had Kubernetes on AWS, but we then fast realized we run out of IP addresses if we don't have any protection in front of that. So there are always some limits that you didn't plan. So things like CloudFlare, others are really good. I would always try to get to bug bounty programs. There you can run that for free with, if you feel good and you trust your developers, then you can do that. It's something everyone can do, or you go to a vendor. And then I would occasionally also do an audit, even if it's a more boring, old-fashioned way. It's good to have people looking at your what you have built, because you get some kind of blind spots, even if you are not the developer in there. And they all lived happily ever after. So now I'm finished.
Yeah, thank you very much, Andreas, for this talk. Very interesting approach to use bug bounties to attract hackers, and in a good way to make your sites more secure. So I didn't see any questions in the chat, so this would be the last chance to write questions to the chat, or we would then switch over to the next speaker.
Maybe one thing, you can also earn a lot of money with bug bounty programs. So you can earn a lot of money with bug bounty programs. So the best one is running on HackerOne. He earns 2 million a year. That's good. It's more than I earn, honestly.
Okay, it's 2 million a year from bugs. That's quite amazing. Cool. So still no questions here.
Good.
So I suggest we move over to the next speaker, Stefan. Thank you very much, Andreas.
Hello everyone, I'm Stefan Birrer from Phenix, and today we're going to talk about our platform and how we deliver real-time video at scale. Our vision is to stream the Olympic opening ceremony to 1 billion people in a personalized fashion, where people can get content that is tailored to their interests, as well as in sync and in real time with other users. Our company was founded in 2013 in Chicago by myself and my partner Scott Puzzletiner, and we grew the company to today about 30 people with offices around the world in North America and Europe. We have delivered a number of firsts in our industry. For one, we delivered an autonomous platform that delivers real-time video on a global scale. We delivered first in-sync real-time video that allows our customers to broadcast video across the globe on many different devices in synchronous nature. We also deliver to a lot of concurrent viewers, over 1 million is possible. We use multiple cloud providers so that we can deliver high availability options. So in case there is an issue with an internet service provider or a region, or even like multiple region of a single vendor, we can sustain our services when we do that. Our technology is used to enable betting use cases. Because of the real-time nature, it enables in-game wagering on horse racing and greyhound. We also deliver sport content with multiple angles that allows viewers to see how the game unfolds from multiple directions at the same time. We also enable monetization strategies that allow our customer to monetize the content that they are giving to their end users. And we have become a partner of one of the largest media companies in the world. So some of the key metrics of our service is that we deliver in less than 500 milliseconds glass to glass from the feed from the camera out to the broadcast-sized audiences. That we synchronize the delivery of those videos in less than 100 milliseconds synchronization window. That we provide extremely fast time to first frame. As you can think of like an e-commerce transaction, every second of latency reduces the transaction volume that you will be able to generate. We operate over 30 points of presence and data center location and serve millions of streams every day. So the key value propositions of Phenix is less than half a second end-to-end latency, broadcast size audiences, and synchronization of the viewing experience across multiple screens. We also offer a secure data channel that allows our customers to build new forms of interactive content. Here's an overview of like how our video workflow works at the high level. We take a video signal from a production center. That could be a camera, it could be in very simple cases a webcam like in this broadcast, or it can be a professional produced video feed from a stadium. It goes over our encoder in real time, sent out to our network, is distributed across the globe, and then distributed to the end users using a WebRTC compliant implementation that we call the Phenix Interactive Transfer Protocol. And all this in less than half a second's end-to-end latency. Below we compare it in kind of the traditional use case where HLS or Dash is used to package the content and distribute it using a traditional CDN and then deliver to the last mile, typically resulting in latencies from 10 to 30 plus seconds. So our autonomous real-time network, one thing that probably will be surprising to most is that despite that we run more than 30 data centers, we have 0 operation people. Our platform is fully autonomous, so we subscribe to a philosophy of zero ops, which means no operating staff, no human supervisors of the platform. The design and the architecture, as we're going to talk in a bit, is from the ground up designed for high availability. So we want to make sure that failures the system will be able to overcome any sort of failures at the micro and the macro scale. For that, the system monitors itself constantly, over 10,000 health checks per second. It heals itself, so if it detects resources that are not performing to specification, they will be retired and replaced. It also scales itself. By monitoring, it also knows kind of the load. At the current level, it has a sense of prediction for the near-term future, and it uses that information to scale itself, and it protects itself. So if there is unexpected low conditions, it will also be able to respond to that and add additional resources as needed, or replace resources that basically are deemed unhealthy. Fundamental to our technical approach is also our engineering approach, because one goes hand in hand with the other. Wouldn't be able to do what we're doing without our engineering approach, and without our engineering approach we wouldn't be able to deliver on our goals in the technical side. So one thing that we set out to is kind of define what is the way of the special forces for engineering. We emphasize strongly on individual contribution, where one engineer is going to be responsible for the functioning of a deliverable piece that they own from end to end, but doing so in a very transparent way. There is a declaration, we have mission statements, success criteria, there is peer review across the process, constant updates of problems, thought process, decisions, and announcement of completion. So everything is up for, in essence, challenge, and we basically learn and iterate, use the collective know-how at every stage to optimize the solution and end up with a result that is repeatable, and it doesn't necessarily mean one engineer will be able to produce a better than other. So everyone should be able to produce at the high level, because they can leverage the collective know-how, even though they are the individual contributor on a certain piece of work. We apply a lot of principle, but ultimately are very pragmatic, right? If all in the end has to work. If it doesn't work, it doesn't matter how many principles we followed. We're a strong believer in QA automation. We have several thousand of acceptance tests that constantly run against our platform. So when a feature gets into staging environment, it will go through a process where it is vetted against this automation and acceptance testing continuously. Then we can do staged rollouts where, with our presence around the globe, we can use a certain subset of the volume, even randomized, to leverage a new feature or an improvement and validate that it actually works the way it should. Here's an overview of how our architecture looks. At the high level, it's a microservice architecture. Maybe not necessarily exactly like some folks are used, but the gist is we have a messaging bus that connects basically everything. All our modules are connected through that bus using a well-defined protobuf implementation interface. And that allows us to create kind of a versioning of APIs as well as maintain forward and backwards compatibility when we roll out multiple versions for a limited period of time. The key components, obviously, we do have endpoints on the HTTP, which we leverage, some third-party services, which we're going to talk in a bit. We have front end, so we separate termination of requests coming in from the internet, being it HTTP or WebSocket. We have services instances that allow us to implement workflows for business logic. We have streaming infrastructure that allows us to deliver a large amount of data to a lot of users. So you see, like, from the thickness of the arrows is kind of where the internet traffic is, whereas HTTP is more of control traffic, and the streaming workload is a WebRTC compliant protocol. We have caching infrastructure where we can cache certain kind of artifacts, for example, a recording of video for replays. We have a key value store that's a memory-based implementation for state. So one of the key aspects of our design is that the state lives in a memory-only implementation, as it's so-called the brain, and all the services that operate on that state that can scale out horizontally will use that state and will not keep any local memory to store essential state of the system. There's some caching, but no, all the true state is in the memory. And this is replicated across multiple POPs which all are connected through the MQ bus. So we have three highly Phenix-specific components. That's basically the front-end termination, where we take HTTP requests and translate them to internal API requests, and they're routed then to the right, either an Anycast location or a specific node for the response. That happens through the MQ messaging bus. We have the services cluster, which runs a number of microservices, which may be different to what you're used to. Like microservice for us is a logical separation foremost. We can split it up easily into multiple clusters, but there's an operation overhead of doing that. And so we run a number of microservices in the same physical process, but isolate them against each other with request rate limiting and so on. And then we have a streaming cluster, and that's obviously where most of our effort goes in. We build a real-time routing network, right? That's based on C++ implementation, standard compliant, but built on with additional proprietary algorithms and improvements that enables our ability to deliver the lowest latency possible across large geographic regions. We also leverage open source components for where we can drive a lot of value without necessarily having to invest our time. Obviously, caching is one. There's a lot of great products for out of that, like Memcache. The messaging bus, a number of messaging bus out there. Like we use AMPQ API, so that it could theoretically be replaced with different implementation. Our favorite is RabbitMQ, has proven itself very scalable, very performant over the years. For key value store, we use Aerospike in a memory-only mode without any disk activity. Even though they're super fast with SSD, we just leverage memory only to make it as fast as it's physically possible. On the streaming nodes, we also leverage some open source tools like FFmpeg. I mean, you know, it's converting different content for let's say HLS and Dash delivery. We have our technology to write this out in real time, and then converting formats, for example, from HLS to Dash is something that we can leverage open source tools very easily without having to spend our time to support another protocol directly. So what we talked about so far is kind of the core of our platform. It's also because we are committed to high availability, we actually never want to depend on a third-party vendor or a third-party service in any of our mission-critical workflows. So all what you're seeing here are, some of them are in a mission-critical workflow, but they're in our deployment, configuration deployment, in such a way that there is a failover mechanism to another means. So we never have a problem where we depend on another service to be online in order for us to deliver on all our mission-critical services. But there are certain things that we leverage, obviously, for storage. We store billions of artifacts every month for video recordings, and so we use Google Cloud Storage for that currently. We have need for analytics, a lot of reporting. So the state is persisted in BigQuery, which is a pure SQL interface. So I like generically simple interfaces that are time tested, like SQL is one of them, right? So I don't necessarily mind using an implementation like BigQuery. It's extremely scalable and cost effective. And if someone knows SQL, we'll be able to use our BigQuery data and create some amazing big data analysis within a matter of minutes. We store several terabytes of BigQuery data a month. We use a third-party monitoring service for our components in mostly a basic fashion, right? We have like some custom metrics, but the amount of data that we collect is staggering. So typically it becomes cost prohibitive to use some third-party vendors at some point. So we have to kind of keep it minimalistic. We use file storage and data storage Firestore and data store to store certain other records, some of them are redundant, and also Firestore mostly for VOD, so that we keep a record of all the recordings that took place in a way that we can query quickly. When I say query, obviously in all the mission critical workflows, we typically do primary key queries. There's not like a select star where X larger 5 type of query in our mission critical, because there is no real-time nature to answering such a query. We also leverage Google Cloud CDM for scale, even though workload for us is only a small HLS and Dash is only a small percentage of our overall load. We move petabytes of data in real time every month. There's an aspect of like how our architecture scales, both inside a data center where these clusters each are scaling out horizontally based on real-time metrics that we collect and feed into our autoscaler, and it makes its intelligence decisions on how many instances of each it needs to run. We also scale horizontally at the macro scale, at the point of presence level, where we run n points of presence, and each of them is capable of delivering the full service. And they work together, connected to our backbone during redundant fiber connections, being able to access any stream in the world from anywhere else, and deliver that in very low latency then from their edge in kind of using the streaming servers to the end users using a very short round trip time on the last mile. And each of those data centers is basically designed, as we discussed before. They have their own state. Some of the state we mirror, so there is a very low latency across the globe when that state is needed to be accessed, depending on the kind of the requirements on how fresh a state needs to be. It's part of our ways. We don't necessarily want to have a strong transactional model. We don't sell. We're not a bank. But what we really need is something that's really fast, right? And has this healing property to always go to the correct state. So that gives us a little bit an ability to use some advanced, kind of pragmatic approaches in how we manage our state across the globe. So with this real-time network that on a global scale, it enables a couple of new use cases. Like one is the ability to deliver one channel to many users, as you can have figured by our broadcast size audiences. We also support group applications where we have a few people stream to a few more. Fan Connect, where you have a few people stream to a lot. So there could be, kind of the new stadium experiences where people sit at home and then it's broadcasted to a lot of people. Because of our ability to scale, without necessarily having to know how much load is coming on the system, we can support scalable inches. That means we could have, some people publishing thousands of channels into our platform, and we can dynamically size the number of instances that we need to run to support that use case. With the low latency and synchronization, we support multi-angle content, so you can have them synced, and virtual couch experiences where you have a few people together communicating with each other, interacting with each other, and watching the same game at the same time, right? And not everyone sees the score at the same time. It's a very important aspect of that. It can be used in the multiple markets. We support sports use cases, betting, trivia, where people can answer questions to win money, esports, low latency is essential, auctions, e-commerce, where people buy goods online, entertainment itself, or social applications. It's kind of like some of the key differentiator to traditional live streaming. So we can provide in-game contest opportunities. You can watch things with friends, multiple angles in synchronization. Can do all kinds of interactive experiences that really add value, differentiation to your products, and obviously reach the broadcast size audiences, and all this while streaming in less than half a second end to end. So here's an example of a virtual couch experience where we have multiple user-generated feeds coming into our cloud. They can be anywhere in the world, right? And then we have like a professional feed coming from the stadium that goes through a Phenix encoder that provides real-time multi-bitrate encoding that can be distributed to many people and provide an adaptive video experience. It goes in our platform. does the magic, right? It scales it, it makes it available on the edges where we need, and then you can basically build an app where you consume both the broadcast feed and the virtual couch experience of the users, and have that all in sync and in real time. Multi-angle, in a multi-angle case, you may have like people in a stadium, obviously broadcasting feed out of the stadium, the same content, multiple camera angles going in our cloud. They have people maybe in the stadium or out the stadium using 5G, other network connections, and we provide the adaptive bitrate technology. Everyone gets the best quality on their device given their internet connectivity. In this case, 5 camera angles. We did multiple more camera angles in some very high-profile events. From a workflow perspective, obviously the ecosystem is so rich, and there's a lot of integration points. I was talking about the pure real-time, less than half a second end-to-end workflow quite a lot. We support other means of for ingest in the stadium, from hardware SDI inputs, from MPEG-TS multicast feed in data centers, or RTMP ingests that go then through kind of our contribution encoding, or potentially some third-party RTMP contribution, comes in our platform, and then is delivered in our network using our global fiber backbone, redundant global fiber backbone. We offer some transformation, right? So you can convert content from real time into live HLS dash. We can use that for replays, so people can do instant replays on a multi-angle experience, and distribute it then on the edge, typically WebRTC compliant in the most volume, but also other protocols like HLS dash, RTMP, to basically every kind of client, supporting legacy use cases for enterprises with IE and so on. So some of our customers include betting customers. RMG starts perform, which will stream horse racing, mostly in the UK, but also a global audience. CIS, similar, has a lot of greyhound races across the globe, almost 24/7, and customers all over the world. In the entertainment space, we hosted companion shows for ABC and Sony, where people could win hundreds of thousands of dollars answering questions in real time and participating in a game. We also streamed behind-the-scenes footage from the Oscars, which allow people to engage in a new way with an existing format, and doing so in less than half a second screen latency. Yeah, sum it up, it's like the 3 big values of Phenix is real-time, in sync, at scale. We were the first autonomous real-time network in the world. We have a strong emphasis on the zero operation paradigm. We're building the special forces of engineering to deliver on our high aspirations. We use a distributed microservice architecture to deliver our platform, and being able to innovate quickly enough without slowing down on maintenance. When we built the platform, performance, high availability, and all these very important goals were there from the day one, right? We didn't start building something that worked and then try to make it high available. We figured, like, this is how we need to build it if we want to make it high available. And last but not least, performance is not everything. It's the only thing, right? Half a second end-to-end latency. Thank you very much.
Thank you, Stefan. So very impressive latency. I think with our YouTube setup, we have around 10 seconds or 10 to 15 seconds. Maybe we need to improve for the CloudFlare game. Maybe that's something that could be used with your solution to get better. Are there any questions from the speakers here? Maybe?
You said like you predict with scaling or something like magic, KI, it scales up, it knows what's coming. So how does it know what's coming?
Well, so you can basically the second and third order derivative of a performance indicator. So you look at like we track, for example, every user that connects to our platform. We know what the request rate is right now. We know how it develops over the last 30 seconds, and we can when you think about, like, you know, a bad example, but it's probably very much. And you look at those COVID waves. It's very easy to see that we are increasing and that it's not slowing down. And so that's when you do the derivative of that function, you will see that there is actually like an increase per rate per second, and that is a very strong indication that we are not peaked yet, right? And so that's one of the ways that it uses to create an indicator that tells it, well, I'm growing at this rate and I probably need this much capacity in 30 seconds or 1 minute. Obviously, the second piece of this obviously is our ability to scale extremely fast, right? It takes a lot less than 30 seconds for us to make an API call until we get a fully operational server in our platform. So that's another part of our innovation where we, in essence, basic essentialism. I didn't talk too much about that, but you know, we don't use too many frameworks for the key part, because you know, if you show me the scalable solution that can scale, or the off-the-shelf solution that scales from one server to 1,000 in less than 30 seconds, I'm definitely interested, but that's what we built.
Yeah, we are using Azure, and if I need an additional server in Azure, it takes, I don't know, a minute, 2 minutes, 5 minutes until this server is online. And you also use, I don't think Google or Amazon is much faster than that.
I mean, my performance number, I mean, look, so all the cloud providers do some optimization. So if you just request the first type of server, that's a different story. But we do this a lot of times a day, and they do also smart things underneath the cover and doing it faster. So for one thing we obviously do, we have, you know, it's a container first architecture, but it's only one container. So all these machines are bootstrapping from the same container. So every single cloud region that we run in has already those instances running. And what happens is those images are therefore in the local cache of that zone. So when we make that request, that part is already pre-cached, right? And then I think just from the volume, I mean, there is probably some other optimization. So if you just request one server, or you know, very unregularly, or don't have running, then these caches will not be as warm as ours, because we do this thousands of times a day. So they're typically, you know, there's some differences between regions, but in the ones where we have a hot usage, the days, it's response time from API to server booting up is it's typically less than 15 seconds.
So what do you say to Tom about zero DevOps?
What's the question?
You say zero DevOps, and we're in a DevOps company. So.
Well, I mean, you know, it depends on the use case, right? But I mean, there is obviously DevOps that operations that takes place in that infrastructure layer, right? We just don't want to own that piece. And the other thing is that we focus on very basic APIs, right? So like the APIs we use for Cloud for our mission critical workflows are create, destroy, or provision, start, stop, depending on the use case, right? What's the fastest one? It's not the same. So you're actually right with the Azure case, like actually our integration, we have an integration with Azure too. So we actually pre-provision the servers and have them sitting in stop state, and we start them up because that's faster than provisioning them from scratch. But that's not the case for every cloud provider. So we figure out which one is the fastest, and that's like there's basically two methods, and we use the faster one. Then we work with them to optimize it. So that's kind of like our typical way of life. And but yeah, the like for us, like we want that to be, you know, like it would be very prohibitive to our business if our engineers would have to know all these cloud specifics, API and behavior, right? I think we want to just use the basic essentials, so that when we go on provider A or we go on provider B, I don't have to train my people to understand the difference. Now there is a little bit of that, let's say the logging interface or some nuance, like, I mean, but I do believe, like, fundamentally, like, since we don't have operations people, we have engineers, so there should be capable enough to open up the UI and figure out how to start the server or how that works, even though they never have to really do it manually, but just that kind of that type of level of operation should be able to do that, right, without having to get a certification in vendor-specific APIs, right? But yeah, it's would not scale for like our team if I had to have them, you know all this vendor-specific APIs.
So thank you very much. Maybe we have still some work to do to do zero ops everywhere, and platforms are changing, so that's good to know that maybe there's still some work left. Okay, thank you very much, Stefan. So we move over now to Uwe from CloudFlare to do the quiz. So give us a few seconds to prepare that. Okay, so Uwe, let's go.
Yeah, thank you very much, Tom. Thank you so much for giving us the opportunity to present our quiz here, the fun part of this evening tonight. And basically, before starting watching Bern playing in the EuroLeague, let's win some prizes. I've put on the screen the details how to attend the game, and I want to ask you please to open your browser on the PC or on a phone and go to kahoo.it, and please enter the PIN displayed on the display and as well your work email address. I also want to highlight the fact that by participating on the game, you basically agreeing that CloudFlare and mine will send you solution-related information and special offers based on our joint solution offering. So please take your time to register. It's kahoo.it. The PIN on the screen displayed 9711864 and your work email account. Thanks so much. So basically, yeah, I'm Uwe Martin. To introduce myself while you're registering, I'm based in Munich, covering the channels for Germany, Austria, Switzerland, working for CloudFlare. And I have to admit, tonight I'm starting my career as a showmaster, as a quiz master. In fact, I've never done this before, so I'm very excited to do it. And also, I want to thank all the presenters for the very interesting evening. So I think it was a great session today. We learned a lot of things, and a special thanks to our friends from apfelkiste.ch, where we have seen how powerful such a delivery, security, performance, scalability platform can be. And of course, they're one of 27 million customers we're delivering today. Also to mention when it comes to the game, that the rating of the game will be based on speed and the correctness of the answer. So there are two components which at the end of the day compile the score. It's, are you giving the right answers, and how fast have you been able to answer? The quiz itself is a fun quiz. So it's more around facts and stats from CloudFlare. And the prizes you can win today are, as we think, very valuable prizes. So you see the Lego Death Star here, which is something which brings us back to the days when we watched those movies the first time. For those who are more sporty between us, so we do have this Apple Watch in here. One of the prerequisites is you're doing sports, and the second one is you have an iPhone to make use of it. And the third one, having the e-scooter in here, which is more or less like a CloudFlare motor, faster forward, up to 22 km/h with a range of 25 kilometers. So you can really speed up your life in addition to the applications on the CloudFlare platform. So basically, this is the quiz. I'm going to start in a couple of moments. Remember, it is the speed and the right answer what at the end of the day will define the score. So let me switch screens to the application itself, so we can start. It takes a little bit of time until everybody is logged in, but we'll do it. So let's see how it looks like. We have some participants in here. I'll give you another few minutes to register. So I'm displaying the registration details again. It's kahoo.it, and you can enter the PIN 9711864 and your work email address. I would say we reached 8 p.m. Let me start the game. You will have 30 seconds to deliver the right answer. It's a fun quiz. Take your time, select the right answer, and win. Okay, cool. So we have 2 correct answers and 1 incorrect answer at this stage of the game. Thank you so much. Let's start with question number 2 out of 10. Absolutely correct. We are present in more than 200 cities worldwide, delivering around 27 million digital properties, as I said before. Thank you so much for your answers. The next question is around the CloudFlare's capacity. How much capacity do we have available to deliver applications on an average? Exactly. 59 terabits a second is the total capacity we see on average while delivering our applications on the web. A huge number, which shows the power of the platform itself. Next question. So this is a local one for the Swiss guys to say so. Where are we present in Switzerland? Correct. Zurich is the right answer. This is where our pub is located, from where we delivered applications on a worldwide basis. So another question, then we reached 50%. Let's see how it goes, and then we take a preliminary score. This is really interesting. I'm curious to see if you know the right answers, because we are really open workspace, and we have over X languages we speak alone in Europe in the offices. That's correct. It's 50 plus languages we speak. This is the result of an internal survey here in EMEA, 50 plus languages in CloudFlare EMEA today. So we reached half time of our game. Dive is leading with 2,249 points, followed by MCO with 2,149. Remember all the prizes you have seen. It's a one choice prize, so the winner will be able to choose one prize out of the three prizes I presented. Let's get to the next question here. What is CloudFlare's average time to mitigate a DDoS attack? Yep, as we are mitigating DDoS attacks at different layers, layers 3, 4, and 7, we have this integrated system to defend all those attack types against the properties of our customers. Two answers are correct. Less than 3 seconds, really fast mitigation. Time to mitigate is the key value when it comes to security. It is a question of fast you're pulling away an attack from your infrastructure, websites, applications. That's the key criteria. Next question, let's see. Number 7, about how many internet property does CloudFlare protect today? Oh my God, I mentioned it. I was talking too much today. $25 million and above is the correct answer. Thank you so much for listening. It was a kind of test question for me. So let's go to the second last question, question number 8, third last question. How old is CloudFlare? Since are we in the market? Correct. 10 years plus. We had this 10 years anniversary recently since CloudFlare has been founded and present in the market. 6 correct answers. Great. Thank you. So now we do have the second last questions announced. About what percent of the Fortune 1000 are CloudFlare customers today? Three seconds. The correct answer is 17%. One correct answer at this stage. And now the final question, very tight scoring here to say so. Let's see how it goes. How long does it take to onboard CloudFlare? Less than 10 minutes. This is really good. Thank you so much. 3 correct answers. So the time to value when onboarding to CloudFlare is really short, and combined with the time to mitigate when it comes to security, we really provide state-of-the-art performance and security solutions to our customers. So let's see what the final score is. And here we go. Place number 3, Mr. Isler. The second one, MKO. And the winner is Dive. Dive, congrats. Remember, you will have the option to choose one of the 3 prizes I presented initially. And we will contact you. I want to share the contact details. Of course, you know Tom and the colleagues in there in the sessions in the presentation. So we will come back as you registered with your email account. We will be able to identify you. And for any other questions to learn more about CloudFlare 9 solutions, you can contact myself or my friend and partner seller here in 9, Andre Kuhl.
Thank you very much, Uwe. I think you did a great job with your first time Quizmaster. You may do that more often.
Maybe I change jobs, let's see.
Okay, and congratulations to the winner. Would be happy if you show some picture if you're riding your bike or whatever you decide to order. Okay, so thank you, Uwe. We say goodbye and we switch back now to the other view here. Bye, Uwe. Okay, so thank you very much for listening. If you like the talk, please give us a like. And if you like to be notified about further Tech Talk Thursdays, please follow us and activate the dongle below. That was it from our side. We see that we have gotten the pizzas for the speakers. So, ein Gute and goodbye.